everyone. Welcome back to Build. I'm Simona Kotin, CDA, and I'm here with Jeff Holland.
Hi, great
Jeff,
to be here.
good to have you. Would you mind telling us what you're doing at Build today?
Sure, yes, happy to. So I'm Jeff Holland. I'm a program manager for Azure Functions. So this is one of my favorite weeks of the entire year because I get to come here and hang out with my people, all these developers who are ready to build exciting things in the cloud, on premises, wherever. So yeah, primarily focused on Azure Functions, Serverless, and all the excitement that brings.
So I must say that Serverless is actually one of my favorite parts of Azure. So I'm super privileged to
I
be
wish
here
you would
with
have finished the sentence where you started. You said it was your favorite, and now it's one of your favorite, but you can't play favorites. That's fair.
Yeah, for a second there, I thought that wouldn't be a good idea.
Fair enough.
Okay, so what do you think about starting with a quickly overview of what Serverless is and when would you use Serverless?
Yeah, for sure, absolutely. Because it is a little bit of a misnomer for a word, and a lot of people are very passionate to let me know that with serverless, there are in fact servers running behind the scenes, and I'm aware of this. But I'll explain a little bit about what serverless is and why it's exciting for developers. So if you think about a traditional task like building a website, a lot of your time isn't just spent building the actual code for the website, but you have to also understand, how am I going to host this website? How am I going to run it? How am I going to make sure that it scales? Like maybe I have a promotion and now 1,000 people are coming to my website every second. How do I make sure that my application can stand that traffic? And do I have to pay for that all of the time? All of these questions. What serverless enables you to do is that you just simply write the code that you want to run in response to any event, and you publish that to Azure. And then we take care of everything else. So we'll make sure that when those events happen, we'll take care of scaling it out to all the servers that needs to happen. We'll make sure that you have the capacity that you need. And the really nice part about it is you're only charged when your function's actually running. So if like a website example, if nobody's coming to your website, maybe it's a weekend or a holiday, whatever, you're not charged anything in your bill. It's only when there's actually things happening that you're charged. So that's kind of the pillars of serverless, and why a lot of developers get excited, because now they can ship applications much faster because they don't have to worry about all these things that you traditionally do with building cloud applications.
That sounds fantastic. I actually gave a talk today about building serverless APIs, and that was exactly what I mentioned as well. I really love the auto-scaling feature, but also not having to pay as much. I feel like as a startup, this has a huge value. You can just get up to speed and build your own product very fastly.
Yeah, it's not my saying, but I have heard it said, and I love it, for serverless, because oftentimes with the cloud you hear about pay as you go, so like you pay as you go. With serverless, it's really pay as you grow. So for like a startup, it's perfect. If you have one customer doing one thing a day, you're only paying for that one thing a day. The very next week, now you have 500 users. Now you're just paying for those 500 users. So it really is just ramping up as you're growing your application, as you're growing your business. So it's a perfect pairing there.
That sounds great. So it almost sounds like you can do anything with serverless, really. Like, would you recommend using serverless for everything? I wouldn't use it for everything.
Well, yes, the answer is use serverless for everything. No, it's a good question. There are some constraints that are worth noting as you're evaluating how you're going to host and manage your application. I think one of the biggest ones is functions are very short-lived and they're stateless. So if you have a task like, I need to go, process an order or charge someone's credit card, that might be a great fit for a serverless function, because it just wakes up, calls the payment API, does its processing, calculates sales tax, and then it goes away. It's gone. Now, there are sometimes pieces of your application that do need to be constantly running. Like an example that I hear from time to time is you have something like a WebSocket. And you need to have a persistent connection to that WebSocket so that you're always listening for data in and data out. Well, since functions can only run for up to 10 minutes at a time, you're kind of running, disconnecting, and then running again. Not a great fit for serverless. That's where you might want to look at something that's more persistent and running 24/7. But anything that is kind of, there's an event, there's a specific event that will start this function, and it is okay to be short-lived. Those are great fits for serverless. If you need more flexibility than that, if you need more control. The other one, I guess, too, specifically around topics popular at Build, maybe you need access to like the GPU and you're doing some really complex machine learning stuff. all of those controls are not given to developers for serverless, so that's where you might need to look at, oh, hey, I need one of these, NVIDIA CPUs in Azure or VMs to do that.
That's a separate thing.
Yep.
Would you mind expanding over, you mentioned there that you will run your function for maybe 10 minutes. Would you mind expanding on why is there a time limit on the function run?
Yeah, and the way to think about it is with serverless, and part of the benefits is we don't have servers running 24/7 with your code. So your code is very short-lived, and in fact what happens is, let's say you've written an Azure function and for whatever reason you haven't called it in a week. We might not actually have any servers behind the scenes in the Azure cloud running your function code on it. So when your event comes in, we have to hurry and provision a server for you. We actually have some that are pre-warmed, ready to go, and get that going for your function. But it's very short-lived. Like we create a server for you, we're like, run this little piece of code, and once it's done, we tear it down and get away with it. And that's happening. We're processing billions of events every day. So there's all of these little things that are popping in and out, popping in and out. With all of that popping in and out, it's not very viable for us to just keep it specific for you because we've got this massive flux of movement. Now, that said, one of the things with Azure, which is worth calling out, is that you can actually choose to write a function using like the function programming model. And instead of hosting it as a serverless function where it's kind of pop in, pop out, pay as you go, you can actually say, you know what, I actually just want to spend $50 a month to have a little piece of machinery in the cloud that's just my box. Like this is my dedicated, it's an app service plan is what it's called. So there is a choice there, but most often what we see developers get excited about is the kind of, I just want this thing to pop in, run my code and go away and be very inexpensive at the same time.
Yeah, especially because you're only paying for what you're using on the consumption plan, whereas with the app service you have a monthly bill, right?
That's right. Yeah, whether it's used or not, and you might even need more capacity or less, you're paying for it in that app service plan, as you said.
It looks like we have a question here. So Jeff, please explain how the serverless function handles the threading programming. Where multiple threads used to run? And is it like every execution is a thread?
It's a really good question. And so the answer is, behind the scenes, as I kind of mentioned, we're popping in your function app, and then we're pulling it away as we need to. And once we kind of create a function app for you to execute on, we will actually send multiple requests to the same instance. So for programming languages like C#, where they're multi-threaded and everything works well, we'll actually leverage all of the threads on the machine so that you can process things in parallel, all on the same instance. JavaScript is a little bit different because JavaScript is a single-threaded language, so there is a little bit of the switching back and forth between threads very quickly. So that is something to be considerate of. It's also something you could take advantage of. So a common example is, let's say your JavaScript function needs to make an outbound HTTP request.
Yeah.
And before you make that outbound HTTP request, you have to create like an HTTP client. You have to have something that can go make that request. In Azure Functions, you can actually make that a shared HTTP client. So now multiple executions can all leverage that same global variable without having to instantiate on every request, which gives you some benefits as well. So it's a really good question. I know there's some complexity there, but it is something to be aware of, that you do need to make sure you have your settings in a way, understanding that the same process, the same threads might be shared across multiple executions.
Okay, that sounds very interesting. That's actually, would you use that kind of model for maybe database connections?
Yes, absolutely. All of those things where it's like, if I'm sending 10 requests a second, I don't really want to have to create a connection to Cosmos DB or to SQL database 10 times every second. Like your database is going to be screaming for help. Your code's going to be really slow because that's an expensive call. So absolutely, you can kind of create this global variable which creates the connection when we first pop in your function. And then you're just reusing that connection across. And if we're adding more and more function instances, it just creates the connection once and is reused. So it's a really good best practice that actually we'll be spending some time, even in a session I have later today, talking about just that. So perfect example.
I'm super happy that I'm here. That was a question that I had in my mind for quite a while. So it's a perfect opportunity. Maybe let's just back up a bit and kind of talk about serverless and JavaScript. Like, how would you get started, and maybe which are the use cases that you think you've seen the most in our customers' applications?
Yeah, it's a really good question. For JavaScript specifically, I would say the best getting started experience go download Visual Studio Code, regardless, even if you're not using functions, go download Visual Studio Code. That is, I'm not lying, I walked through the expo hall earlier today and I saw out of the corner of my eye that there's a Visual Studio Code booth, and I had to run down there and just tell them, like, you all rock, like this team is so cool. So download Visual Studio Code, and one of the awesome things that the Visual Studio Code team has shipped is an Azure Functions extension.
I love it.
It's really convenient. So you don't have to even, if you want to start in the Azure portal, you can, but honestly, if you're a JavaScript developer, you should be using Visual Studio Code anyway. Install that extension. It has guided walkthroughs to help you create your first function app. It's got templates for you to get up and started really quickly. One of the great things with Azure Serverless 2 and tools like Visual Studio Code is that you can actually run and debug your Azure function completely on your local machine as well. So if you want to test your code, call it a few times before you publish it, Visual Studio Code handles all that for you, breakpoints, debugging, all the coolness that VS Code brings. I think for JavaScript specifically, the scenario that I see the most interest in is I'm building a web application. Maybe I'm using Angular or React or Vue.js, and there's something on the server that needs to execute. I think I used the example of a store before. I know Sarah Drasner, one of our MVPs, has a great blog post on having a Stripe store using the Stripe payment API. But when it makes to make that call to Stripe, it goes and calls a function. Because again, like I'm kind of in my HTML, CSS, JavaScript. I don't want to have to now shift my thinking and go figure out, well, shoot, how am I going to host this logic? Like, what am I going to do?
Yeah.
So you can almost just add that JavaScript as a simple function in Visual Studio Code, test it, publish it to the cloud, link your website to that. Now you have this website which can now call these serverless APIs behind the scenes.
What I really love about the integration with VS Code and Azure Functions is that you can actually, you can use even like the extension to publish your function. You can use the extension to edit app settings or create app settings. So it's almost like 99% of the time, I don't even have to go back to the browser, back to the portal. I just can focus on the local experience, and then from there, make sure that everything works fine in the cloud as well. But it's just great. I love it. We have to give a shout out to Matt, right?
Yes, Matt Hernandez.
Yeah,
honestly,
Matt Hernandez. Yes. He's the guy.
He is, honestly. Follow him on Twitter if you're not already. He is the guy.
Yeah. We do have a few other questions. So what's the plan for custom languages in V2 and future runtimes in functions?
Sure, yeah, there's a lot in that question, so I'll peel it apart a little bit too. So today, generally available, we do have what we sometimes call version 1. I know that's not super clear. In short, it is Azure Functions written on top of .NET Framework. And one of the parts of the current generally available version is that it is locked on specific languages. So it can support JavaScript, but it only supports Node 6, like Node version 6 is the runtime. It also supports C# and F#. In preview right now, and you can test this out today in Visual Studio Code, Visual Studio, or the Azure portal, we do have another version of Azure Functions, and one of the benefits that that version brings is that we can actually now run different languages outside of that .NET kind of home that it usually runs in. So that gives us a lot of flexibility. Right now you can run Node version 8 for JavaScript functions. We've already started working on the work so that Node version 10, which is just rolling out now, so that you could also use Node 10. And additionally, other languages too. So we have a lot of flexibility in what languages we support and how we support them. So with work that's coming out, there is documentation on GitHub. If you go to github.com/Azure Functions, and I think there's a dash in between those two words, there is some docs where you can actually experiment and try building your own language extensions. It's pretty experimental. Like, I wouldn't say everybody go do it, but if you're like a hacker by heart and you're like, I want to do this, we have some interesting ones on GitHub where people have written some different languages. Internally as a team right now, we're investing a lot in, I mentioned, kind of different versions of JavaScript. Java right now is in preview. Python is now supported as a language extension as of today, as of this conference. We've got a few more in the pipeline that I guess I'll save for another one of these broadcasts. But yes, good question.
That sounds awesome. Yeah. We do have a few other questions. Can we have different languages with different functions? For example, using C# for fetching users, and Python for data manipulation, and JavaScript for
back it like
an
web
API.
development. Yeah. This is actually one of the cool things about functions that I don't get the chance to talk about that much, where there definitely are tasks that different languages seem best suited for. Like if I want to do something with machine learning, a lot of people are like, oh, Python is probably the best fit.
Yeah.
If I'm doing something where I have like a single page application backend, I probably want to have that in JavaScript if I'm writing my single page there. And you do have that flexibility with functions. You can write one function in C#, and even in the same app, write a different function that's in JavaScript and a different one that's in Python. So you can choose as a developer what is the best language that I'm most comfortable with and is best for the task that I'm accomplishing, and pop that in wherever you want, and you don't have to kind of pick favorites and mix and match wherever you want to.
I love it. It's really cool. I'd like to spend some time talking about a few extensions that I really love.
You seem excited to
yeah.
talk about them, so I'm excited to hear.
Tell me more about durable functions.
Ah, yes, durable function, the new hotness, I would say.
Agreed.
So one of the challenges that we've even kind of talked about here with serverless is that these are generally very short-lived functions, like 10 minutes or less. But sometimes you have processes that might actually run much longer than that. Or even different, you might have these kind of microservices or nanoservices. And maybe for a process to complete, there's actually 5 of them that need to get called. So we've kind of been using this store example. I'll stick with it. Let's say somebody places an order on your website. And more than just charging their credit card, you also need to send them a receipt through email, and you need to create a shipping notification with FedEx, and you need to let your inventory database know that they need to go pick this thing from the warehouse. So there's a bunch of different components that all need to happen in a specific order. And doing that traditionally with serverless is really difficult. You have to kind of break things apart, manage queues in the middle. So what durable functions allows you to do is still in your code, as an Azure function, write these complex orchestrations, where you can have a number of different patterns to actually call different functions. So maybe, do function 1, function 2, function 3. You can call functions in a loop. You can split things out and parallelly have things execute. There's quite a bit there. It's quite advanced. And at Build, we've announced this is now generally available to write those orchestrations in C#. And now in preview, we actually let you write these in JavaScript too. So if I was writing my serverless store and I wanted to be able to, charge their credit card as function 1 and send them email as function 2, now I could just write this little piece of orchestration also in JavaScript that would say, call function 1, then call function 2. And we'll make sure that we do that. Like we give you guarantees around durability. If one of your functions erupts into flames for whatever reason, we'll retry that and make sure that everything works out and that that completely executes in a durable fashion.
I think that's great. That's really cool.
Did I miss anything? Because you know a little bit about this too. I don't know if there's anything worth...
I mean, one of the things that I've been exploring is the difference between durable functions and logic apps.
Yeah.
And I think that what I've noticed is that with logic apps, it tends to be better to use logic apps when you want to use some of the connectors, like hundreds of connectors that are available out there. Whereas with durable functions, when you want to just write code, that's what you would use, right? I got that right.
That's it exactly. Ship it.
Woohoo!
That's perfect. Yes.
Okay, another question regarding dependency injection and Azure functions. Is that available?
There's a lot there. You sound like you're really excited about it. I can definitely answer this though, so don't worry. Again, so this is more C# focused, .NET focused, but there's a concept in .NET, specifically in other languages I'm sure, I'm just more familiar with it here, where a function may have different dependencies. Like it may depend on a specific version of a logger, like to create log messages, or different versions of other things. And a common way to solve this is by injecting those dependencies into the function before it executes. So specifically for this is something that is not available today magically out of the box. There are a few blog posts that if you're interested, I can think of like 2 or 3 off of the top of my head where some developers have written ways to kind of have dependency injection concepts in functions. The thing I'll mention on this, and to make sure that I don't have everybody else get lost in the weeds, this is a scenario that we care about. So we are actively working on work right now so that that version of Azure Functions that's in preview, we will enable you to do your own injection at some point in the future. And so we've got to figure out the contracts and the right way to do it so that you can have kind of your startup.cs file to let you define your injections and do it in a good way. So nothing today that is great for this, but definitely a valid ask and something we want to support.
I imagine this would make even more sense when we're talking about durable functions, because we're maintaining context there, and if we're using
Sure. Yes.
dependency.
Yeah. And as soon, especially dependency injection comes up a lot when the process gets much more complex. And durable is a big thing where like now this is much more than just add A and B. Now you're doing a lot of different pieces. So being able to pull in the right dependencies at the right time and have flexibility to test each piece individually is an appealing scenario that we want to light up.
Yeah. Okay, so we have, I think, 4 more minutes, and I know that you were on the keynote.
Oh,
Congratulations.
yes.
For those of you who haven't seen Jeff on the keynote, he had an amazing demo. Would you like to spend some time talking about that?
Sure, I will. That was a unique opportunity. That was really exciting. So one of the things that we've been focusing a lot on as a company and moving towards into the cloud are actually 2 of my favorite things. This was like the combination of 2 of my passions. One is serverless, which we've been talking a lot about.
Yeah.
And the other is IoT. I love IoT. Like on my personal blog, I've been playing with Raspberry Pis and video doorbells and all this stuff. It's just, I think it's so fun to be able to manipulate devices in the physical world. So for the keynote, what we showed, first in the serverless realm, is with tools like serverless, you can have an IoT scenario and have it completely written and published in just a few minutes. So the gimmick with my demo was 5-minute timer. And this was all real. None of this was pre-recorded. I was up there typing those words.
I've seen it.
With the I can't remember the stenographer, the people in the courtroom who type. Apparently, I could have been a great one because I was typing very fast. But within 5 minutes from scratch, we wrote a serverless app to respond to IoT events, so that when you press a button, it sent a tweet to the world. I really wanted a blade to like slowly be lowering while the time went down, just to add more suspense. But I guess the fire marshal wasn't okay with that.
Yeah, you basically finished ahead of time as well. So instead of spending 5 minutes, you spent 4 minutes to just send a tweet to the world when you push a button.
Push the button.
I'd love to be able to do that. Like in 4 minutes,
you
send
could.
a tweet
The buttons
to
are
the
there.
world.
I'll give you. I've got one in my bag, Simona. I'll start the timer for you.
Thank you.
And then the other piece was, one of the things with serverless and IoT is sometimes you don't want to have to push all that data up into the cloud. I think a huge scenario that you've probably been hearing a lot about this week is things like machine learning. It might just make a lot of sense to do that on the edge. Like if I want to talk to my personal assistant, or if I want facial recognition, I don't want to have to deal with the latency or maybe privacy concerns of sending all that data to the cloud. So we extended that, and instead of pushing a button, we wrote a Scott or Not app, very much inspired by the Silicon Valley show and HBO. So there was a Raspberry Pi that I wrote that could recognize Scott Guthrie, and when Scott showed up, it saw him right away. It recognized him all running on that Raspberry Pi, and then sent a tweet as well. So a really fun demo to build. That was one that I built myself, like the whole code for all of that. The code is all there. I just followed public docs. It was a really cool experience, and I was glad for the chance to get to show that off yesterday during the keynote.
Yeah, I'm always enjoying following your blog posts. You always build really cool stuff. Like I love the doorbell thing where you identified people.
That's
no,
right.
you didn't run machine learning on that. Right?
There is, so I call one of the cognitive services in that one too, where at my doorbell at my house, so if you ever come and visit, it will actually call cognitive services to do analysis on the video stream from the doorbell.
Can you do like, yeah, I'm not sure if I like this guest, so probably I'm just gonna ignore it. Is that what you use it for?
Yes, that's exactly right. It's like, oh, yeah, I'm not home right now.
Yeah, it's Mona, no. I think we have time for one more question, maybe.
Sure.
Yeah. So can we save the output of a function app? Any plan to have local simulator?
Save the output, and what was the last part? I was following the question.
Any plan to have local simulator? So I think our runtime is.
It is local, and like there are different pieces that run locally. So if you're using like Azure Storage, you can do that entire development all locally on an airplane without Wi-Fi, Azure Function calling Azure Storage locally. There are pieces right now that don't have a local emulator. I think Cosmos DB, for instance, there is no local emulator. So if you want to do that, unfortunately, we're constrained by what can run on your machine. But if it can run local, SQL, storage, whatever, you can definitely debug and monitor that all today.
And we're also working on building all those tools so that they run locally, and not only on a Windows machine, but also on a Mac machine.
Yes,
as
yes,
well,
that's true.
right?
One of the things I've been trying to follow along is how do we get that nice local storage experiments that's today on Windows and make it so that if I'm developing on my MacBook, I can still get those same benefits.
I'm excited about all the things that your team is building. Thank you so much, Jeff. This was a lot of fun. Thank you for tuning in, and hope to see you around.
Hey, thanks so much.